This is Trig. Section 3.1. Radian Measure. So what in the heck are radians anyway? Well, when we talk, usually we talk about degrees. And I'm going to use this really great picture. This goes from 0 degrees to 90 degrees, 180 degrees, 270 degrees, and 360 degrees all the way around. Degrees, that unit has a little bit of a problem because it's more than just a number. It's a number attached to this conversion that you need to go back to the circle. We know that the circumference of a circle is 2 pi r. It's also pi d, but 2r is 2 radians, same as the diameter d. So if we take and think of that circle as a big circumference, then this is when you have 0 radians because the radius hasn't started yet. But if you move up here, this distance, the length of one radius, you have the angle measure of 1 radian. And as you go around the circle, how many radiuses do you have? Well, back to this, you have 2 pi radiuses, or radii. So 2 pi radii is really all the way around the circle. 2 pi radians. What does that mean? Well, the first pi is here, the second pi goes to about here, the third pi about here, not the third pi, first radius, the second radius, the third radius, the fourth radius about there, the fifth radius is about here, and the sixth radius, as you measure around, is about there. How much is 2 pi? Well, about 6.28, approximately. There are about 6.28 radii in a circle. Now these have an advantage in some ways over degrees because this is just a number. This is like 12 eggs, a dozen eggs. This is just the number of radii that you're measured. So it's not got this unit attached to it, this degree mark. So if you'd like to change though, just like you change from inches to centimeters, do you guys remember that? There is a ratio, inches to centimeters, there's 2.54 centimeters per inch. Or you can do 1 over that if you want inches per centimeters. Well, we're going to use, because we know that 2 pi is 360 degrees, they are really the same as far as the circle is concerned. But we don't need the 2 in there, so we'll divide both sides by 2, and we'll get 180 degrees. This is going to be our ratio, pi over 180, or 180 over pi, just like this is the centimeters over inches, or inches over centimeters, feet to yards, things like that. So what is 30 degrees in radians? Well, we want to get rid of this degree and introduce the radians. So you put the degree in the denominator because you want to cancel the degrees. And in the numerator, put the radians. So this becomes 30 degrees pi over 180 degrees. But the degrees cancel. So it's really just that number. Well, if you divide these by 10, you get 3 pi over 18. And finally, divide both numerator and denominator by 3, you get pi over 6. So 30 degrees is the same as pi over 6 radians. Let's do a couple more, but maybe backwards. Suppose you have 120 degrees. How many radians? Well, remember, we're changing to radians, so that goes in the numerator. We're getting rid of the degrees, that goes to the denominator. We have 120 pi over 180, because the degrees cancel. Divide by 10, you get 12 pi over 18. Divide each of those by 6, you get 2 pi over 3. 120 degrees is 2 pi over 3 radians. How about 3 pi over 2 radians? Now sometimes radians is a unitless measure. You don't put the mark like you do with degrees. You don't put an R. You don't even say, well, not even say it, but you don't write the word radians unless you really need to. I'm going to say this is 3 pi over 2 radians. It really goes in the numerator, right? So I want to get rid of the radians, so I need to use the pi in the denominator, because that's the radians, and the 180 degrees is what I'm introducing. So the radians cancel, and I get 3 times 180 degrees over 2, because the pi's also cancel. Now 2 goes into 180 90 times, so it's 90 degrees, and 3 times 90 degrees is 270 degrees. So 3 pi over 2 radians is 270 degrees. So what's the rule? And I guess to me you don't memorize the rule so much as just makes sense. If you want to change from degrees to radians, you got to cancel the degrees, put the 180 in the denominator. You want to change from radians to degrees, you got to cancel the radians and introduce this degree, so put that in the numerator, the radians in the denominator. Also, we will make an agreement. We will agree. This agreement is on page 86. Sorry, 96. If no angle measure, no unit is given, could be degrees, minutes, seconds. There's also a measure called gradians we'll talk about in a second. We assume they're talking about, and I will assume this on a test, radians. Okay? So make sure you put that degree mark. That now becomes very important. There are other degree or other measures, things called gradients. Now I just bring this up in case if you get into engineering, they use this in engineering. It was when they were trying to change everything to the metric system and change everything to powers of 10, right? The kilometer, the meter, the decimeter, all those powers of 10. So in this case, the normal 90 degrees you're used to, they said, okay, we're going to make that 100 degrees gradients, though, is what it's really. So now what is the circle? That is 400 degrees, or gradients. A semicircle is 200 degrees, and of course a right angle is no longer 90 degrees, it's 100 degrees. I don't think it caught on. I'm not even sure they use it at all today in engineering, but that's the only place they've ever brought it up. So we're going to continue with some examples. The first one, page 98 to number 6. And this is where I get to practice my drawing. Moving stuff around. Okay, tap this or something. So my circle's gotta get better. Oh my gosh. We're gonna take and change the color. Here is the initial side. This is in standard position, and we've got an angle that's going to go over here, and we're going to measure it this way. This is our angle theta. So, directions. Each angle theta is an integer, plus or minus 1, plus or minus 2. See, we need some steps here. Plus or minus 1, plus or minus 2, plus or minus 3, etc., etc. Measured in radians. Give the radian measure of this angle theta. Well, let's see. We're going, it's got to be negative. So first of all, let's put a big negative sign there. And it's just past this first mark. So how do you remember some of that stuff? Well, let's go back to, that's a little bit better. Circle. If this is 0 radians, 90 degrees is pi over 2 radians. Well, that's 3.14 divided by 2, or 1.7, and that's all you really need. So this is approximately 1.7. Right here is pi, which is approximately, I guess I should use a squiggly, 3.14. And this is 3 pi over 2's, which is approximately another 1.7 added to this. So it's 4.84. And 2 pi, if you double the pi's, you get 6.28. So they're saying this spot right here is what? If we go that far past this 1.7, it's really looking at something right around in here. Well, if this is 1.7, and that's supposed to be an integer, then I bet you that is 2. And if you do that in the negative direction, it's a negative 2. So all this green will give you the 4 steps you need. Well, I watched my last video, and this it's taken a little bit of practice to learn this tablet. But one of the things that I shouldn't have done is not dividing 2 into 3.14 correctly. Let's see here. 2 goes into 3 once. That's a 2 here. You subtract to bring down the 1. 2 goes into 11, and there should be the decimal. 5. 2 times 5 is 10. You subtract and bring down the 4. 2 goes into 14.7. So pi is 3.14. Pi over 2 approximately. Pi over 2 is approximately 1.57. And 3 pi over 2 is the 1.57 plus the 3.14, which is 11, 5, 6, 7, yeah. Those look wrong to me when I did them before, but I didn't catch it until after we were all done. 4.7 and 1.57 doesn't change that last problem we did. But I just wanted to make sure you didn't carry those numbers along, which were wrong. Pi over 2 is about 1.57, pi is 3.14, 3 pi over 2 is 4.71, and 2 pi 6.28. Those are the numbers you should be using. Okay. Now, problem number 22. Problem 22, the directions are: convert each degree measure to radians, leave answers as multiples of pi, and for 22 it's a negative 1800 degrees. So, if we want to change that to radians, multiply by, need to cancel this, so the pi goes in the numerator, 180 goes in the denominator, the decimals cancel. And now we've got to do some reducing. Remember, we're supposed to leave this in terms of pi, so don't touch the pi. But this 1800 divided by 180, there's one more 0 here, right? So if we take a look at that, and maybe we can do this so we can get our 4 steps. 180. So that 0 cancels with the 0, and the 18 cancels with the 18. So you say there's 0 over 18? No. This is really still 1 and a 0, and this is just a 1 in the denominator. So it's not 0, it's 10 pi. Oh, gosh. So let me do that. Negative 10 pi, which hopefully makes sense to you. And that should be our 4 steps. Number 44. Convert the radian degree to degree measure given 15 pi. We could have used that for part of our steps. Convert. Multiply by, and now we got to introduce the degrees and get rid of the radians. If you want to make it with 4 lines instead of a cross, which sometimes may not get counted as the same number of lines. So this is, let's see, 15, put everything here, pi, 180 degrees, the denominator's pi, so these will cancel. Hopefully you've got more room on your paper. What's 15 times 180? 5 times 0, 5 times 8 is 40, 5 and 4 is 9, 1 times 0, 1 times 8, and 1 times 1, 17, 2700 degrees is 15 pi. Sometimes it's good to check these by just saying, does that make sense? It's a little harder with the radians because you're not used to that. But hopefully this one you could see, if it's a negative 1800, which is 10 times 180, That's like 10 times pi. So hopefully that makes sense. This 15 pi, if one time around is 2 pi, then this is like 7.5 times around. So what's 7.5 of 360? And maybe that should give you the same number here, because 15 then 180. Anyway, sometimes that, just looking at it, doesn't make sense. 15 pi is pretty big. So now, number 56. Convert each degree measure to radians. But these are going to not be so nice. This is a negative 23.0143. Well, this time it's not going to be so nice to cancel and stuff. When we convert it to radians, pi goes in the numerator, 180 degrees, so you can cancel the degrees. In these cases, we'll do our answer to 4 decimal places. On the test, make sure you look for that to see what I've asked for. I think I'll probably ask for this so we all do the same. That means I've got to put all this stuff, the negative 23.0143 times the 3.1415, etc., that your calculator has, divided by 180, because the degrees cancel. And how do we get this to work? Well, we bring up our calculator, turn it on. Let's see here, let's clear this out. So it's a negative 23.0143 times pi, which is second, this caret or exponentiation, divided by 180. So use your calculator's approximation for pi, and it gives you the negative 0.40167. See, I said 4 places. Negative 0.4016. If it was 67, then we'll go one more place. 0.4017. Let me take a look at that again. I lost it when I touched the screen. Yeah, that should be good. Okay. That's number 56. And another one. Number 64. Convert to degrees. Write answers to the nearest minute. So now they get specific. And 64 is negative 3.47189. Now these are in radians, so you need to introduce the degrees, cancel the radians, so to speak. Let's get our calculator out. Clear this. It's a negative 3.47189 times 180 divided by pi so we need 4 steps. I'm going to write this down. Negative 1989246. Negative 1989426. But our calculator can do this. This is degrees, since I introduced that. Let's let our calculator do some of this work. So I'm going to convert this, in angles, second halves, to DMS, number 4. So I'm going to take that answer and convert it and get negative 198.55. They said nearest minute. So negative 198.55. And last but not least, number 86. Find the exact value of each without using a calculator. So 86. The cosecant of a negative 13 pi over 3 okay, I'll get better at these circles eventually. So 13 pi over 3. If we want to think of this as pi's, 13 divided by 3, 3 goes in that 4 times, that'll be 12. And 1/3, right? So this will go 4 times, but these are pi's. 1, 2, 3, 4 times, and then 1/3 of a pi, which is that pi over 3 spot. So the reference angle is pi over 3. And what you'll find is, this is going to be negative. So if it was positive, it would be that. Since it's negative, it would be going clockwise, and the 1/3 would be here. But the reference angle is still pi over 3. It's just now in the 4th quadrant instead of the 1st quadrant. The cosecant is negative in that quadrant. And pi over 3, let's see, the tangent is sine over cosine, and we need the cosecant, right? So that's 0, 1, 2, 3, 4 over 2, and it's 0, pi over 6, pi over 4, pi over 3, pi over 2. So this is the square root of 3 over 2, except it's reciprocal. 2 over the square root of 3, which is the same as a negative 2 times the square root of 3 over 3.